bilinear transformation. Bilinear transformation. First one. Find the bilinear transformation. Find the bilinear transformation which maps z1 is equal to -1, z2 is equal to 0, z3 equal to 1 into w1 equal to 0, w2 is equal to I, w3 is equal to 3I. Solution. We have to consider the bilinear transformation. W is equal to AZ plus B by CZ plus D. So that is equation number 1. Next go for case 1. Case 1. Put Z is equal to -1 and W is equal to 0 in equation 1. So equation 1 become W is 0. 0 is equal to AZ plus B. AZ, what is Z? Z is -1. AZ plus B by C. Z is -1 plus D. Cross multiply. 0 is equal to -A plus B, or it can be written as -A plus B is equal to 0. So that is equation number 2. Next go for case 2. Case 2, put Z is equal to 0, second values, Z equal to 0 and W is equal to I in equation 1. So equation 1 become W, what is W? W is I is equal to A into Z plus B by C into Z plus D. Therefore from this what we got? I is equal to B by D, or B is equal to ID, B minus ID equal to 0. So that is equation number 3. Next case 3. Case 3, put Z is equal to 1 and W is equal to 3I in equation 1. So equation 1 become W is 3I is equal to A into Z plus B by C into Z plus D. Cross multiply. 3I into C plus D is equal to A plus B. So A plus B minus 3IC minus 3ID equal to 0. So that is equation number 4. Now, which two equations we should consider? So if you see equation 2 and 3, AB is there, BD is there, A, B and D. Only 3 unknowns. Yes. So we can consider equation 2 and equation 3. Right? 2 and 3. If you consider 2 and 3, what you will get? Equation 2. Equation 2 is AB, 3 is BD. AB, BD. So if we consider these two equations, minus A, consider equations 2 and 3. Consider equations 2 and 3. 2 and 3. See what we will get. 2 and 3. What is equation 2? Minus A plus B plus 0D equal to 0. Now equation 3 is 0A plus B minus ID is equal to 0. Now I will use the Cramer's rule. A by the determinant is equal to minus B by the determinant is equal to BD, ABD, D by the determinant. Now don't consider coefficient of A, consider coefficient of B and D. 1, 0, 1, minus I. Next b by minus 1, 0, 1, 0, 0, minus I. Next d by the determinant minus 1, 1, 0 and 1, 0 and 1. Therefore a by minus I plus 0 is equal to minus a by minus into minus plus I minus 0 is equal to b by minus 1 minus 0. So a by minus I is equal to minus b by I is equal to d by minus 1. We can take that minus here, multiply by minus sign. So we obtain a by I is equal to b by I is equal to c by 1. Therefore, what is a value? A is I. Therefore, a is I. B is minus I. It is not C, it is D. Okay. B is I, not minus I, plus I. And D is equal to 1. And D is equal to 1. We substitute A, B, D values in equation 4. In equation 4. Therefore, equation 4 become A. What is A? A is I. A is I plus B is I minus 3IC as it is because we have to find C minus 3I. What is D? D is 1 is equal to 0. So I plus I is 2I. 2I minus 3I. 2I minus 3I is minus I. Minus 3IC is equal to 0. So that is minus 3IC is equal to I. C is equal to minus I by 3I. I and I cancel. That is what is C? C is minus 1 by 3. C is minus 1 by 3. Now we have to substitute A, B, C, D values in equation number 1. Okay. So now equation 1 become W is equal to A. What is A? A is I. A is at plus B is I. A z plus B by C z. C z plus D. What is D? D is 1. Okay. Now we have to do the simplification. Take 3 LCM in the denominator. Iz plus I divide by, if you take 3 as LCM, minus z plus 3 by z. So it becomes, so divide by 3. Denominator of the denominator is multiplied to the numerator. 3, take I common, z plus 1 by minus z plus 3. So this is what we have. Let's go here. So this is the transformation for the given points. We go for the next problem. The bilinear transformation. Find the bilinear transformation which maps z is equal to infinity I 0 into W is equal to minus 1 minus I minus 1 minus I. This is minus I minus 1 minus I and 1 and 1. Also find the fixed points of the transformation. Also find the fixed points. Also find the fixed points. Also find the fixed points. Of the transformation. transformation. Fixed points is nothing but invariant points. Solution. So we have to consider bilinear transformation. W is equal to AZ plus B by CZ plus D. For this equation number 1, we go for 3 cases. Case 1, what is the first case? Put Z equal to infinity and W is equal to minus 1. Put Z is equal to infinity and W is equal to minus 1 in equation 1. So equation 1 becomes W is minus 1 is equal to A into infinity plus B by C into infinity plus D. See, here we have infinity. A into infinity is infinity plus B is infinity only. By C into infinity is infinity plus D. That is infinity by infinity. Infinity by infinity is indeterminate form. We cannot find the solution for this. Then what we have to do before going to substitute Z as infinity directly? So what we should consider in the RHS? We have to simplify to not get the indeterminate form. For that what I will do? I will take Z common in the numerator of the RHS. So it becomes Z into A plus B by Z divided by Z. Take Z common in the denominator also. It becomes Z into C plus D by Z. Z and Z get cancelled. Now you put Z is equal to infinity. B by infinity becomes 0. D by infinity becomes 0. The value will not be indeterminate form. Therefore now put W is equal to minus 1 and Z is equal to infinity. C plus D by infinity. So this value will be 0. This value will be 0. Therefore it becomes minus 1 is equal to A by C. A plus 0 is A, C plus 0 is C. Therefore now it can be written as minus C cross multiplication. Minus C is equal to A or A plus C is equal to 0. Call this equation number 2. Next go for case 2. What is case 2? Put W Z is equal to I. Put Z is equal to I and W is equal to minus I into equation 1. So equation 1 becomes W is minus I is equal to A into Z. Z is I plus B by C. Z is I plus D. Now cross multiply. Minus I into IC plus D minus I into IC plus D is equal to IA plus B. Okay, now multiply I into I square is minus 1. That is minus into minus plus C minus ID is equal to IA plus B. IA, take these two terms in RHS, IA plus B minus C plus ID is equal to 0. That is equation number 3. Case 3. Put Z is equal to 0, Z is equal to 0 and W equal to 1. Z equal to 0 and W is equal to 1 in equation 1. So equation 1 become W. What is W? W is 1. 1 is equal to A. What is A? A into 0 plus B by C. Z is 0 plus D. So this implies 1 is equal to B by D. 1 is equal to B by D or B is equal to D. B minus D is equal to 0. So that is equation number 4. Now we have to see equations 2, 3 and 4. So 2, 3, 4, here we have AC, here we have BD. So total 4 variables it will come. So if you will see 2 and 3, here we have 4 variables, here we have 2 variables. We require 3 variables. Then what we can consider? Shall I solve equation 2 and 3? If we solve 2 and 3, C and C will get cancelled. Okay. So next I will consider equation 2 plus equation 3. So what is equation 2? A plus B plus 0, you take A plus 0B plus C plus 0D equal to 0. This is our equation 2. Equation 3 is IA minus plus B, IA plus B minus C plus ID is equal to 0. Now simplify this. Minus C plus C get cancelled. So 1 plus I into A, if you add this, plus 2B, 0B plus 1B is 1B only. Next, 0D plus ID is plus ID is equal to 0. Call it as equation number 5. Now we can consider 4 and 5. Here we have BD with A. Okay. So for that consider 4 and 5. Consider equation 4 and equation 5. What is equation 4? I will take that as 0A plus B minus D equal to 0. Equation 5 is 1 plus I into A plus B plus ID equal to 0. Next, now we have two equations with three unknowns. We can use the Cramer's rule. So A by the determinant is equal to minus B by the determinant is equal to C by the determinant. So A by the determinant, don't consider A coefficients. B and D consider 1 minus 1, 1 I. Next, minus B by the determinant is 0 minus 0 minus 1, 1 plus I and I. Next, D, A, B, D, not C, it is D. D by the determinant, 1 plus I, 1 plus I, 0 minus 1, 0, 1. 0, 1, 1 plus I, 1, 1 plus I, 1. So now we have to simplify this. I will simplify here. Next, A by the determinant. 1 into I is I, minus into minus plus 1, I plus 1, right? Is it right? Next, minus B by, so 0 into I is 0, minus there in the formula, minus into minus plus, 1 into 1 plus I is 1 plus I. 1 plus I is equal to D by the determinant, 0 minus 1 plus I. 0 minus of 1 plus I. We have 1 plus I, 1 plus I, 1 plus I in the denominator. So multiply by 1 plus I. So we obtain A by 1 is equal to minus B by 1 is equal to D by minus 1. You can keep this minus here. Therefore, A is equal to 1, B is equal to minus 1 and D is also equal to minus 1. So we got A, B and D value. We should find out C. So where we can substitute? Here if you substitute A value, you will get C. Okay. So I will go for the next page. Next. Substitute A, substitute A is equal to, what is A? A is, what we got here? A is 1. Substitute, or we can take it as equation 2 become A plus C is equal to 0. That is C is equal to minus A. What is A? A is 1. Therefore, C is equal to minus 1. Now substitute A, B, C, D values in equation 1. So equation 1 become W is equal to A. What is A? A is 1. A z plus B. What is B? Minus 1 by CZ. C is minus 1 into Z plus D. D is minus 1. Therefore, we obtain Z minus 1 by minus of Z plus 1. Take minus to the numerator. It becomes 1 minus Z by 1 plus Z. This is a transformation for the given set of points. In the question, continuation of this, we have also find the fixed point of the transformation. Fixed points is nothing but invariant points. Okay. To find fixed points of the transformation, points of the transformation, put W is equal to Z in equation 5. Where is equation 5? You call this as equation number 5. Right? Already we given the number equation 5. We are given, right? So you take this as equation 6. Equation 6. Okay. Now equation 6 become W is equal to Z. That is Z is equal to 1 minus Z by 1 plus Z. Cross multiply. Z into 1 plus Z is equal to 1 minus Z. Z plus Z square minus 1 plus Z equal to 0. Z square plus 2Z minus 1 is equal to 0. It is not possible to factorize, so we have to use the formula method. Z is equal to minus b plus or minus root of b square minus 4ac by 2a. Therefore, z is equal to minus 2 plus or minus root of 4 minus into minus plus 4 by 2. So that is z is equal to minus 2 plus or minus root 8. Root 8 can be written as 4 2s are 8, 2 root 2 by plus or minus 2 root 2 by 2. Take 2 common, minus 1 plus or minus root 2 by 2. So 2 and 2 cancel. Therefore, invariant points are minus 1 plus root 2 and minus 1 minus root 2.